Hello, good morning everyone. My name is Rafael B. Canseco from Bsmare and I'm from Group 9 and my other members are
Lukay James Roday from Bsmare 1 Alpha.
I'm JB Lukay from Bsmare Engineering 1 Alpha.
So in this activity, we will collect a water sample from school boiler water, seawater, and rainwater and analyze it for total suspended solids and pH. Measuring TSS help us understand the concentration of particle matter such as slit organic debris or microorganisms suspended in the water, which affects clarity treatment requirements and potential health impact. Determining pH indicates the acidity or the water, a critical factor influencing chemical reaction, corrosion potential in pipes, and overall stability for drinking and other uses.
And our objectives is to collect representative water sample from the school like boiler water, seawater, and rainwater without introducing contamination, and to determine the concentrations of total suspended solids in the sample by gravimetric filtration, and to measure the pH of the water sample accurately using calibrated pH meter or indicator strips. And lastly, to interpret the results in terms of water quality standards and discuss potential sources of suspended solids and pH deviations.
Today I will discuss the methods, the material and methods. First, clean labeled sampling bottles, glass of high density polyethylene. Next, glass fiber filters, pre-weighted and filter holders. Next, oven or drying chamber set to 103 or to 105 Celsius degree. Next, analytical balance meter calibrated or pH indicator strips. Next, beakers, forceps, and gloves. Of course, distilled water for rinsing, and marker and notebook for labeling and recording data.
In our first session of our activity, we focus on determining the amount of total solids or TSS in different water samples like tap water, salt water, rainwater, and boiler tank water. However, we were only able to test the boiler tank water due to time and equipment and other specific reasons. Thus, the other samples like tap, salt, and rainwater were marked as NA, meaning they were not tested during this session. We filtered 35 milliliters of boiler water using pre-dried filter paper that weighed 0.3483 grams. After filtering, the mass increased to 3.3987 grams. Subtracting the initial weight, we calculated the amount of suspended solids trapped by the filter paper. This resulted in a TSS of 3.054 grams, which indicates a relatively high concentration of suspended solids in the boiler tank water. This could be due to scaling or residues from the heating process in the boiler tank. For alkalinity testing, we recorded the pH of the boiler water at 8.34, which fall under the alkaline range. So, for phenolphthalein, alkalinity was recorded as 0, meaning there were no hydroxide or carbonate ions present in a high amount. However, methyl orange indicated moderate alkalinity with an estimate of around 60 to 100 milligrams per liter, as this shows the presence of bicarbonate ions, which is typical in boiler feed water. Tap, salt, and rainwater were again marked as unknown due to the same limitation, and no alkalinity data was collected for them.
For the second session, hardness, phosphates, and chlorides. During the second sessions, we analyzed the hardness, presence of phosphates, and chlorides ions in 3 samples: boiler water, seawater, and steam water. Each sample was measured at 5 mm. Seawater showed a salinity level of 3%, while both the boiler and steam water had zero salinity. The alkalinity tests were conducted using indicators, phenolphthalein and metal orange, with 2 drops of each added to the samples. Then we added the standard acid to see when the color change occurred. This helped determine the endpoint for titration. For seawater, 5 drops were needed with phenolphthalein and 3 drops with metal orange before any color changes were noted. Boiler water required 5 drops of phenolphthalein but shown no change even after adding metal orange, which could mean that buffering agents are lacking or used up in the process. Similarly, the steam water required 10 drops of phenolphthalein and 6 of metal orange, also with no visible changes, suggesting low buffering capacity of very low alkalinity. As for results, all 3 samples were classified as hard water, meaning they contained significant amounts of calcium and magnesium ions. None of the water samples shown the presence of phosphates, possibly due to the absence of agriculture runoff or detergents. However, chloride ions were present in all 3, especially in seawater, where salt content is natural high. The presence of chlorides in boiler and steam water could be due to dissolved salts from source water or contamination.
Session 3, Alkalinity and Dissolved Oxygen. In the third and final session, our goal was to determine the alkalinity and the presence of dissolved oxygen or chemical oxygen demand in the same 3 water samples: sea water, boiler water, and steam water. Again, we used 5 millimeters of each sample and added 2 drops of phenolphthalein and 2 drops of methyl orange to each. Seawater requires 5 drops of standard acid for the phenolphthalein endpoint and 4 drops for methyl orange, with the color turning dark. This color change indicates strong alkalinity consistent with its high salinity and mineral content. Boiler water needed for 5 drops with no noticeable change in color, while steam water required 10 drops for phenolphthalein and 7 for methyl orange, turning yellow. This color outcome suggests varying alkalinity levels, with seawater being the most alkaline, followed by steam water and then boiler water with the least. The lack of significant color change in boiler water further confirms that its alkalinity is minimal, possibly due to prior treatment process that removed carbonate and bicarbonate ions to prevent scaling. Meanwhile, the distinct color shift in sea and steam water may indicate the presence of dissolved oxygen, especially in the steam water, where the yellow hue hints at moderate COD levels.
So to summarize, our 3-session experiment allows us to evaluate the physical and chemical characteristics of different water sources. In session 1, we focus on total suspended solids and pH, where only boiler water was fully tested. In session 2, we involved in checking for hardness, phosphate, and chloride ions, showing that all tested water samples were hard and chloride were present across the board. Lastly, session 3 revealed varying alkalinity and possible oxygen levels in the samples, especially in sea and stream water. This finding gives us a better understanding of water quality parameters, essential for industrial and environmental monitoring. So that's all for our video. Thank you everyone, and God bless.